Okay, 9.3 day 3, we're going to use the unit circle and see why it's useful. But first I'm going to remind you that the unit circle has a center of 0, 0. It has a radius of 1, which means if I go to the side, this is 1, 0. If I go from the origin up, that's 0, 1. If I go from the origin to the left, I get negative 1, 0. And if I go from the origin down, I get 0, negative 1. Okay. I'm going to draw an angle in theta in standard position. So this is theta. I'm going to drop an altitude. Okay, and say the ordered pair here is x comma y. Because this is the unit circle, the radius is 1. So if you recall, that meant that the sine of theta is going to be y over 1, which is just y. The cosine of theta is going to be x over 1, which is just x, and then the tangent of theta is y over x because it's opposite over adjacent. Okay, so now we're going to do this with the unit circle. Okay, so the unit circle for the pi over 4 marks is listed below. Let's look for the sine of 3 pi over 4. Okay, I want the sine of 3 pi over 4. I'm not going to use my calculator. I'm going to use my unit circle. Okay, according to this, the sine of theta is the y coordinate. Okay, so all I need is the y coordinate at 3 pi over 4. So I go to my unit circle and I look for 3 pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4. This is the x coordinate, this is the y coordinate. The y coordinate is root 2 over 2, so the sine of 3 pi over 4 is root 2 over 2, and that's the exact answer. Okay, what about the sine of 3 pi over 2? Okay, sine. Cosine is x, sine is y. So I want the y coordinate at 3 pi over 2. So this is 1 pi over 2, 2. There's 3 pi over 2 right here. The y coordinate is the second one, so that's the negative 1. Okay, and you could check that on a calculator if it was in the right mode. Okay, sine of 5 pi over 4. Sine, cosine is x, sine is the y coordinate. So find 5 pi over 4. There's 5 pi over 4. The y coordinate is the second one. So the y coordinate is negative root 2 over 2. Let's keep going. Okay, cosine. Cosine is the x, sine is y, cosine x is alphabetical. So at pi, look for pi, there's pi. The x coordinate is the first one. So the cosine of pi is negative 1. The cosine of 7 pi over 4. 7 pi over 4. Cosine is the x coordinate. Okay, cosine of pi over 2. Cosine is the x coordinate. Where's pi over 2? It's way up there. So this is pi over 2. The x coordinate at pi over 2 is 0. Okay, now let's do some tangent. Tangent is the y over the x, or its opposite over adjacent, or sine over cosine. So 3 pi over 4. Let's look at 3 pi over 4. At 3 pi over 4, over here, the x is negative root 2 over 2, and the y is root 2 over 2. So let me go back. So I'm going to do the y. Over the x. The x was negative root 2 over 2. Okay, if I do root 2 over 2 divided by negative root 2 over 2, something divided by itself, I get negative 1. Because they cancel, but it's negative. Okay, 2's cancel, root 2's cancel. Okay, let's do tangent of 0. Remember, tangent is y over x. So I'm going to go to 0. Where is 0? Here's 0. 0 is 1, 0. So this is the x, this is the y. So I'm going to do y divided by x. 0 divided by 1, 0. Okay, tangent of 7 pi over 4. Where's 7 pi over 4? Right here. Okay, I want to do the y divided by the x. Okay, the root 2 over 2 is canceled, the 2's canceled, the negative stays. So my final answer is -1. So it looks bad, but it simplifies. Okay, we're going to do the same thing here. This happens to be the circle that has pi over 6 and pi over 3 on it. Okay. But it's the same idea. So cosine. Cosine is the x. It's alphabetical. Cosine x, sine y. So 5 pi over 6 is over here. The x-coordinate of 5 pi over 6 is -√3 over 2. Cosine. Cosine is the x-coordinate, 0. 0 is here. The x-coordinate at 0 is the first one, so it's 1. Sine. Sine is the y-coordinate. 11 pi over 6 is here. The y-coordinate there is -1/2. Okay, tangent. Oh, tangents, you do have to do some work. It's the tangent is y over x. So let's go to pi over 3. At pi over 3, the y is √3 over 2 divided by, what's the x? 1/2. Oh, that looks tricky, huh? They both have the over 2, so the over 2's cancel. So then I have √3 over 1. √3 divided by 1, just √3. Okay, let's keep going. Sine of 0. 0, sine is the y-coordinate, so at 0, the y-coordinate is 0. Uh-oh, tangent again. Okay, tangent of pi. Pi is over here, so I'm going to do the y divided by the x. 0 divided by -1 is 0. Okay, tangent again. Y over x. Where's 3 pi over 2? 3 pi over 2 is down here. So y divided by x. Okay, now if I do -1 divided by 0, you can't divide by 0. If you have a 0 at the bottom, it's undefined. That's why it was like not in our domain when we did domain. So if there's a 0 at the bottom, undefined. Okay, sine pi over 3. Sine is y. Where's pi over 3? Pi over 3 is up here. The y is √3 over 2. Okay, cosine 4 pi over 3. Cosine is the x. We'll just cut 4 pi over 3. There's 4 pi over 3. The x coordinate is -1/2. Oh, we got another tangent. Okay, tangent 5 pi over 3. There's 5 pi over 3 right here. So tangent is y over x. X is 1/2. Okay, the 2's cancel, and I have -√3 divided by 1, which is -√3. Okay, tangent again, pi over 6. Where's pi over 6? Up here, pi over 6, y divided by x. Y divided by x. Okay, the 2's cancel again, which is great. Okay, but I still have 1 over √3. So be careful, the √3 is on the bottom. I cannot leave it like this. I need to rationalize the denominator. So I'm going to multiply by √3. So I'm going to have 1 √3 at the top. √3 times √3 is 3. So my tangent of pi over 6 is √3 over 3. Or you can put a 1 in the front here. Okay, one more. 11 pi over 6, tangent. Tangent, y over x. 11 pi over 6. There we go, right here. The y is -1/2. Divided by the x. The x is √3 over 2. Okay, the 2's cancel. Perfect. Okay, let me write my answer. On the top, I still have -1. On the bottom, I have a √3. I'm going to rationalize it. If I multiply by √3, I get -√3 over 3.